Hi, I hope this video finds you doing well. In this video, we're going to be looking at problems in section 3.3 and continuing to talk about synthetic division. So let's get started. Our first problem asks us to use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first, and then we'll be asked to give a reason for our answer. So our first part, we have x to the 7th minus 128, and then we have x minus 2. Now remember, with synthetic division, our powers have to be in descending order, and we can't be missing any powers. So notice here we're missing the x to the 6th, x to the 5th, x to the 4th, and so on. So I fill in a 0 for those missing powers. And don't forget about that minus 128 at the end. Here, because we have an x minus 2, it's not just 2 or negative 2. We take the opposite of what's with the x. So I'm going to put 2 in the box. List your coefficients. And bring down the 1. 1 times 2 is 2. Add that to the next column. 0 plus 2 is 2. 2 times 2 is 4. Plus 0 is 4. 4 times 2 is 8. 0 plus 8 is 8. 8 times 2 is 16. 0 plus 16 is 16. 16 times 2 is 32. And 0 plus 32 is 32. 32 times 2 is 64. 0 plus 64 is 64. And 64 times 2 is 128, leaves us with 0. Again, our problem asks us to decide if the second polynomial is a factor of the first, and so we look at that remainder. If the remainder is 0, then yes, the second polynomial is a factor of the first. So here, yes, x minus 2 is a factor of the polynomial. Because the remainder is 0. So let's look at part B. In part B, we have x to the 4th minus 6x cubed plus x squared minus 6x, and our second polynomial is x plus 6. Again, with synthetic division, our powers have to be in descending order, and we can't be missing any powers. So notice here that we are missing the constant. And so even if it's just the constant that's missing, we fill in a 0 for that constant. Once again, because I have x plus a number or x minus a number, I put the opposite of that number in the box. So here I put negative 6. List your coefficients and bring down the 1. 1 times negative 6 is negative 6. Add that to the next column. Negative 6 plus negative 6 is negative 12. Multiply negative 12 times negative 6 gives me 72. Add that to the next column. 1 plus 72 is 73. 73 times negative 6. Is negative 438 plus negative 6 is negative 444, and we multiply negative 444 by negative 6, gives us 2,664. Add that to 0 and we get 2,664. Again, because we're asked to decide if the second polynomial is a factor of the first, we're going to look at that remainder. The remainder here is not 0, so no, x plus 6 is not a factor of the polynomial. Because the remainder is not 0. So look at number 2. In number 2, we're given a polynomial. 6x to the 4th minus 13x cubed minus 4x squared plus 23x minus 12. Here we're given our k value is 1, and we're told that 1 has a multiplicity of 2. When I see that multiplicity of 2, what that tells me is this comes from a parenthesis that's squared. Or it's what we call a double root. So we'll use synthetic division. Notice that I'm not missing any powers, and my powers in my polynomial are in descending order. I put the 1 in the box, and this time, because I don't have x plus or x minus, I just have k equals 1. I don't take the opposite of it. List your coefficients. Bring down the 6. 6 times 1 is 6, and I add that to the next column. So negative 13 plus 6 is negative 7. Negative 7 times 1 is negative 7. Add that to the next column. Negative 4 plus negative 7 is negative 11. Negative 11 times 1 is negative 11. Add that to the next column. So 23 plus negative 11 is 12. Then 12 times 1 is 12. And add that to the last column gives us 0. Now here, because we're told that we have a 0, that k is a 0, we better get a 0 here at that remainder. If not, then we've done something wrong somewhere along the way. Now, multiplicity of 2 means I can use 1 as a 0 again. So I'm just going to use this bottom row of synthetic division. And I'm going to put the 1 in the box and bring down the 6. 6 times 1 is 6. Add that to the negative 7. Negative 7 plus 6 is negative 1. Negative 1 times 1 is negative 1. Add that to negative 11, gives us negative 12. And negative 12 times 1 is negative 12. Add that to the last column, gives us 0. And again, I know I should have a remainder of 0 here because we're told that 1 is a 0 with a multiplicity of 2. Now, as I get ready to write my polynomial, I'm going to write x minus, my 0 here was 1, so x minus 1. And I write that parentheses twice because I had a multiplicity of 2, or because I used synthetic division twice here. I got a 0 the first time and a 0 the second time when I used synthetic division. Now, in my original problem, my power was an x to the 4th. Remember, your powers decrease every time you divide. So on this line, I would have had an x cubed, and here an x squared. So as I continue to write my polynomial, I have 6x squared minus x and minus 12. My directions ask me to factor into linear factors. Well, linear factors means a power of 1 in each parenthesis. So I'm going to bring down the x minus 1, and I'm going to go ahead and write that as x minus 1 squared because that parenthesis is multiplied times itself. That's where the squared comes from. Then draw your two parentheses to factor our trinomial. To get 6x squared, I need a 3x and a 2x. My signs are going to be a plus and a minus, and I'll figure out which one goes where here in a minute. If I put the 4 here and the 3 here and a negative and a positive, that's going to give me that negative x in the middle. And so now I have my polynomial factored as linear factors. Look at number 3. Our polynomial is x to the 4th minus 2x squared minus 16x minus 15. And we're given 1, 0 here, negative 1 plus 2i. And we're asked to find all of the other zeros. To use synthetic division, my powers need to be in decreasing order, and I can't be missing any powers. Well, once again, I'm missing a power, so I fill in a 0 for that missing power. Put your k value in the box, so negative 1 plus 2i. And notice I didn't take the opposite of it because it gave me my value. It didn't give me x plus something or x minus something. And list your coefficients. Now, because of that I, I'm going to leave a little bit more space in between each of my coefficients. Bring down your 1. 1 times negative 1 plus I is negative 1 plus 2i. Add that to the next column, so 0 plus negative 1 is negative 1, and bring down the plus 2i because there's nothing like that. Then I multiply the negative 1 plus 2i that's here with the negative 1 plus 2i in the box. And use FOIL to multiply. And I'm going to come on down a little bit further. So my first term would be 1. The outer is minus 2i. The inner is minus 2i. And the last is 4i squared. Put your like terms together. So that gives us a negative 4i. And remember, I squared is negative 1. So at the end, I have 4 times negative 1, or negative 4. I still have like terms. 1 minus negative 4 is negative 3. And bring down the minus 4i. This is what I add to that next column. So we had negative 3 minus 4i. Add your like terms, so negative 2 plus negative 3 is negative 5, and bring down the minus 4i. Now once again, I multiply my number on the bottom row of synthetic division times the box. So I'm going to say negative 5 minus 4i times negative 1 plus 2i. Negative 5 times negative 1 is my first term of 5. The outer, negative 5 times 2i is negative 10i. The inner, negative 4 times negative I is positive 4i. And the last, negative 4i times 2i is negative 8i squared. Once again, put your like terms together. Negative 10 plus 4i is minus 6i. I squared is negative 1, so negative 8 times negative 1 is a positive 8. And we have like terms, so 5 plus 8 is 13. And bring down the minus 6i. We're going to add this value to the next column. So we had 13 minus 6i, I believe. Negative 16 plus 13 are like terms, so I add those together and bring down the minus 6i. Now, once again, I've got to use FOIL, and I'm going to multiply negative 3 minus 6i times my number in the box, which is negative 1 plus 2i, and use FOIL. Negative 1 times negative 3 is 3. That's our first term. The outer would be a negative 6i. The inner is a positive 6i, and the last is negative 12i squared. Bring down the 3. Our 6i's cancel out here because one's positive and one's negative. I squared is negative 1. Negative 12 times negative 1 is a positive 12, and 3 plus 12 is 15. And so I add 15 to that last column, which leaves me with 0. Now, I know that if I don't get 0 here, I've done something wrong because the problem tells me that k is a 0 or 1 0 is given. So let's think about our second 0. Our polynomial has a highest power of 4. And so what that tells me is I'm going to end up with 4 different zeros. If negative 1 plus 2i is a 0, its conjugate, negative 1 minus 2i, is also a 0. So I'm going to use synthetic division, very similar to what I did on problem number 2, where I used that bottom row of synthetic division. Now, I can only do this if that remainder is 0. Bring down the 1. 1 times negative 1 minus 2i is negative 1 minus 2i. Notice here that our I terms cancel out. And negative 1 times negative 1, or negative 1 plus negative 1 is negative 2. Then I'm going to multiply negative 2 times negative 1 minus 2i. When I multiply here, I distribute. So that gives me a positive 2 and a positive 2i. And that's what I'm going to add to the next column. A positive 2, and I'm sorry, 2 times 2 is 4, so this would be plus 4i. I knew when I said 2i that was incorrect because my i's were not going to cancel out. So we have 2 plus 4i. Notice once again that the i's cancel out here, and this leaves us with negative 3. Then I distribute negative 3 to negative 1 and negative 2i. Negative 3 times negative 1 is a positive 3, and negative 3 times negative 2i is positive 6i. Once again, notice that those i's cancel out. When you use synthetic division that second time with the conjugate, notice that it's a lot easier and the i's cancel out every time. And we're left with 0. My problem started with an x to the 4th. So this first bottom row would have been x to the 3rd. The power decreases by 1. And then the last time we used synthetic division would have been x squared. So now I have x squared minus 2x minus 3. Our problem asks us to find the 0, so I'm going to set that equal to 0. This problem factors as x minus 3 and x plus 1. Set each factor equal to 0. And so I have two other zeros. One is 3 and one is negative 1. So my other zeros here, one of them was the conjugate, so negative 1 minus 2i. Then we had 3 and negative 1. Problem number 4, we have a polynomial that's given. X squared times x squared plus 1 quantity cubed times x minus 3 quantity. And we're asked to find the zeros and to state the multiplicity. So I take each factor and I set each factor equal to 0. Use the square root property to solve that first equation, so the squared goes away on the left side. Typically with the square root property, we have the plus or minus, and I'd have the square root of 0. The square root of 0 is 0, and there is no plus or minus with 0. Then to solve the second equation, I subtract the 1 from both sides. And we get that x squared is -1. Use the square root property again, so that squared goes away on the left side. And we'd have plus or minus the square root of -1. Well, the square root of -1 is I, so we'd have plus or minus I. And then in the last equation, we add the 3 to both sides, and we get that x is 3. Now I think about my multiplicities. So as I look at this first 0, which was 0, I look at the power of that x. Now notice the x is not in parentheses, so I look at the power of the x, and the power of that x is 2. And so 0 has a multiplicity of 2. My next set of zeros were plus or minus I. This time we have a parenthesis, so rather than looking at the x, the power of the x, I look at the power of the parenthesis. The power of that parenthesis is 3, and so our multiplicity is 3. Our last 0 was 3, and I look at the power of that parenthesis. The power of this parenthesis is understood to be a 1, and so 3 has a multiplicity of 1. Number 5 asks us to find all the possible rational zeros. Our polynomial is 3x cubed minus 4x squared plus 5x minus 9. To find the possible rational zeros, the first thing I do is I find p. Now p is the factors of the constant. Our constant here is 9. And so the factors of 9 are 1 and 9 and 3 and 3. So 1, 3, and 9. Now I like to list those factors in increasing order. To get a -9, I could have a +1 or a -9. I could say -1 times +9. Or I could say +3 times +3 or -3 times -3. So notice that each of these has a plus or minus in front of them. Now my second step is to list Q. Q is the factors of what we call the leading coefficient. The leading coefficient is the number in front of the highest power. So here, 3. And I want to look at factors of 3. Well, the factors of 3 are 1 and 3. And to get the +3, I can multiply a +1 times a +3, or a -1 times a -3. So notice again, I've got those plus or minus. Then my third step is to take P over Q. So first, I would have 1 over 1. Then I would have 3 over 1. And then I would have 9 over 1. Then I'm going to take the 1, I'm going to put everything, all the p's over 3. So I would take the 1 and put it over 3. I would put the 3 over 3. And the 9 over 3. Notice I have 6 values here and 3 values here and 2 values here, and 3 times 2 gives me a total of 6. That way I know I've got everything in my list. Simplify each of these fractions to find your possible rational zeros. One over 1 is 1. 3 over 1 is 3. 9 over 1 is 9. 1 over 3 is 1/3. 3 over 3 is 1. It's already in the list. And 9 over 3 is 3. It is also already in the list. So these are all of my possible rational zeros. Now these are possible. It doesn't mean they are definite zeros. Look at number 6. The polynomial that we're given is 3x cubed plus 8x squared minus 15x and plus 4. Our directions ask us to find all the zeros. Now, I know that I'm going to have 3 zeros because my highest power is 3. I'm going to start by finding the possible rational zeros like we did in problem number 5. So P, the factors of the constant, I think about the factors here of 4. Well, the factors of 4 are 1 and 4 and 2 and 2. And so I'd have plus or minus 1, plus or minus 2, and plus or minus 4. Second, I want to list Q, the factors of the leading coefficient. Well, our leading coefficient here is 3. And the factors of 3 are 1 and 3. So I'd have plus or minus 1 and plus or minus 3. Then I list all my P's over all of my Q's. Now remember we said in the last problem, I have 3 here and 2 here. And 3 times 2 is going to give me a total of 6 for my P's over my Q's. So I start off by saying 1 over 1. Then I'm going to say 2 over 1. And then 4 over 1. And then we have 1 over 3. We'd have 2 over 3. And 4 over 3. And notice we do have 6 different P's over Q's. Simplify each of these to find the possible rational zeros. And so we'd have 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, 1 over 3 is 1/3, 2 over 3 is 2/3, and 4 over 3 is 4/3. Then I'm going to use synthetic division to see which of these is actually a 0. And remember, if it's a 0, our remainder will be 0. Our polynomial function had no powers missing, and our powers were in descending order. So I'm going to start with my first number in the list, which is positive 1. And I'm going to list my coefficients from my polynomial. So I have 3, 8, negative 15, and 4. Bring down the 3. 3 times 1 is 3, plus 8 is 11. 11 times 1 is 11. Plus negative 15 is negative 4. Negative 4 times 1 is negative 4. Plus 4 is 0. And so I have a 0 here. Sometimes you get lucky and you find the 0 on the first try. If you didn't find the 0 with the 1, try negative 1. If that doesn't work, try 2, then negative 2, and so on. My original power was an x cubed. So that means when I use synthetic division once, that power is an x squared. That power decreases by 1. So I have 3x squared plus 11x minus 4. And I'm trying to find the zeros, so I'm going to set that equal to 0. This one does factor. I need a 3x and an x. 4 and 1 and plus and minus. Then set each factor equal to 0. By the way, if you didn't want to factor here, you could have used the quadratic formula. So 1, 0 is negative 4. Add the 1 to both sides of that first equation. Divide both sides by 3. And we get 1/3. So our zeros here were 1, that was the first 0 that we found, 1/3, and negative 4. Number 7, our last problem for this video. We have f of x equals negative 2x cubed plus x squared minus x and plus 7. Our directions ask us to use Descartes' rule of signs, and we're going to think about the number of positive zeros, the number of negative zeros, and then we'll also relate that to our imaginary zeros. So first, let's think about the number of positive zeros. What we do is we look at our coefficients and we look at how many times the sign changes from a negative to a positive. So notice here I have a sign change. From plus x squared to minus x, that's a sign change. And from minus x to positive 7, that is a sign change. So the number of positive zeros is 3. Now there is a little bit of a catch here. If you remember back in problem number 3, we talked about that negative 1 plus 2i was a 0, and that meant that negative 1 minus 2i was also a 0. That is 2 different zeros. Because my conjugate zeros come in pairs, in 2s, I have to subtract 2 from my number. So 3 minus 2 is 1. So I could have 3 or 1 positive zeros. Students will often forget about this other number. To figure out how many negative zeros, I plug in negative x everywhere that there's an x. So I bring down the negative 2, and I'm going to plug in negative x for that x and keep your cubed power. Plus, plug in negative x in place of the x. Keep the squared. Plug in negative x and bring down the plus 7. Remember, when we cube a negative, our answer is still negative, so that would be negative x cubed. When we square a negative, it becomes positive, so we have x squared. Negative times negative is a positive x, and don't forget about that plus 7 at the end. Negative 2 times negative x cubed is positive 2x cubed. And just like I did for the number of positive zeros, I look here at my simplified version, and I want to see how many times the sign changes in front of each of my x's, or my constant. Notice there's no sign changes here. So what that tells me is the number of negative zeros is none. Again, because there are no times that these signs in front of my numbers change, I have no negative zeros. If I had gotten, well, let's just say I had 4. Just like I did with the number of positive zeros, I would say 4 minus 2 is 2, and then 2 minus 2 is 0. You always have to subtract out 2 with Descartes' rule of signs until you get to either a 0 or a 1. And again, that's because of those complex zeros coming in pairs. Now, the last thing that the instructors may or may not ask on the test, but students will see it in math labs, is how many imaginary zeros. And so what I like to do is make a table. I have a table that has imaginary, positive, negative, and total. So we could have had either 3 or 1 positive zeros, and we had no negative zeros. My total is 3 here because that's the highest power. And I want the number of positive plus the number of negative to equal that total. Well, 3 plus 0 plus what equals 3? Well, the answer would be 0. Then I ask myself, 1 plus 0 plus what equals 3? Well, the answer is 2. I hope this helps you as you help our students with section 3.3. If you have any questions, please don't hesitate to ask. I hope that your semester is going well. I will talk to you later.